very specific to a case like horizontal projection of projectile. That means from the top of a tower, we are throwing an object with velocity u, and the velocity is in horizontal directions. That means we are throwing like this. So this means that the x component, if it is the x direction, x component is ux, which will be there, but uy component will be 0 because the vector is around the horizontal directions. So its perpendicular component, if I am taking uy, this will be 0. So this object does not have any vertical component, right? So now I have to get the time of flight of this object when it will follow this trajectory and it will reach the ground. So I have to calculate the time with which it will reach the ground. So in my case, I will consider the vertical motions, because in vertical motions it will reach from here to here. So but its initial velocity uy is 0. So let the equation is y is equal to uyt plus half gt square, where we are taking g as an positive because we are taking it like in downward motions. So g will be positive and uy, I already told that u will be 0. So y will be half gt square. Now we have to get the value of t. So y will be h here, because if we take this height as an h, so it will be like 8 is equal to half gt square. So t will be is equal to root over of 2h by g. So this will be the time of flight for an object throwing in a horizontal direction from a height of a tower. So if you see that the initial velocity is not in this formula, that means the time of flight is independent of its initial velocity. It only depends on the horizontal, the vertical height, right? So if you want to, if you want to increase the range, you have to increase the height, right? So that's all about the horizontal projections, and follow my sessions. I will cover the few other cases on projectile motions. Okay, thank you.